So either we can spend the next 30 minutes just answering questions and plan to see if we have other questions and other...
There are a few journalists in the room. If they'd like to ask you questions, this might also be a good time to do so.
Yeah, so we can go back to the video if you want. And yeah.
Shreya is saying, can you please explain the ice albedo feedback once again, if possible?
Okay, so this is, as I said, one of the most important feedbacks that we have in the system. Okay, so let's say right now, since the industrial level, there was a little ice age in the 17th, 18th century you may have heard of, where large part of Europe were much colder and there was ice down to England. There are stories of how England lost its wine production because of it, and people were skating on the canals in Netherlands that was so cold, and glaciers in the Alps were down into the towns. Now, if you go in the same place, glaciers have retreated. There is no glacier in the UK. UK has switched to beer production, doesn't produce any good wine. Netherlands is in fact having very little winter canal freezing now and so on. So what happened since the Industrial Revolution? We started to warm the climate by increasing the greenhouse gases, the CO2 in the atmosphere. We started to trap more outgoing long wave radiation. What did this warming do? Initially, the warming basically started to increase evaporation from the oceans, from land, from lakes, and so on, and increase the water vapor in the atmosphere. Water vapor is a greenhouse gas in the sense it allows, it absorbs some of the short wave that is coming in, but it absorbs a lot of the outgoing long wave radiation. So we measure greenhouse gas effect in terms of carbon dioxide. If carbon dioxide is 1, then methane is about 25 times as effective as carbon dioxide in absorbing outgoing long wave, and water is about, 10 times as effective. So increased water vapor in the atmosphere, because I hope everybody understands that warmer air holds more water vapor. So naturally increases evaporation from the surfaces. So more water vapor in the atmosphere began to increase the temperature, and slowly we had temperatures increasing. This began to melt the glaciers in the Alps first. Not Greenland, not Antarctica, which had huge inertia because they are very thick. Glaciers flowing down the mountains, they are pretty thin, right? So they began to melt. Glaciers are bright, so they have a high albedo, which means they reflect a lot of the sunlight. So they cool the temperatures because of this reflectivity. If you melt the glacier, you increase the absorption capacity, or you reduce the reflectivity. Ground is darker. If vegetation grows, vegetation is darker. If you build an urban center, it may be different, but nonetheless, in general, glacier has high reflectivity. I hope you can imagine it. Snow is bright. Ice is bright. Not as bright as snow, but it's bright. It reflects sunlight, right? So reduced glacier increased the absorption of solar energy, which warmed the Earth's temperature further, which increased the water vapor further, which increased the temperature further, which melted more glacier. And soon you had Argentary Glacier in the Alps, for example, go retreat quite a bit. You can go to Columbia Glacier. Almost all the glaciers, land glaciers that are small mountain glaciers, are retreating. Again, Himalaya is complicated because it has these valleys where air can dump more snow and so on. So ice albedo feedback is essentially where a change in temperature changes the glacier extent, increases or decreases, which changes the albedo, increases or decreases, which changes the amount of energy being absorbed, increases or decreases, which changes the temperature, increase, decrease, which has a feedback. It is positive in both directions. If glacier begins to grow, reflectivity begins to increase, glacier begins to grow more because it makes the temperature colder. If it begins to melt, decreases the albedo, increases the energy absorption, and melts faster. So the main thing to remember is that ice albedo feedback is positive in both directions, but it is very fast in the melting phase, and we are in the melting phase now. But it is much slower when it is building, as I said, because colder air will hold less and less water vapor, which means the snowfall rate in cold temperatures at higher latitudes or higher altitudes will begin to decrease as the temperature decreases. So building a glacier is a slow process, melting a glacier is a fast process. Okay.
Is this the same as colors? Like, for instance, when they say you wear cool colors or warm colors. So if you're wearing a white shirt, because it's white, it reflects more light away and heat away from you. And if you wear a black or blue shirt, it absorbs more heat. So the darker the color of the water, the darker the color of the snow, it reduces
black car, rooftops. You color the rooftops white, you will reduce building temperature. You have a black car, you have warmer temperatures inside. It's all, albedo is directly related to how sunlight is reflected or absorbed.
Sankalp has another question. So you mentioned that the 1.5 target set by the IPCC is not enough, and that it is better to focus on decarbonization. I wanted to know, given the current focus on temperature targets everywhere, what would be a more realistic temperature target to present to those engaged in this debate, and if possible, to account for overall decarbonization while doing so?
Well, first of all, I want to clarify. I didn't say 1.5 is not enough, or 2 is enough, or 3 is enough. I'm saying global mean temperature targets can be tricky because global mean warming of 2 degrees does not tell you what that means for a specific place. For India, a global warming of 1.5 doesn't mean anything for India because India will be much warmer than 1.5. It'll be having more heat waves, more extreme rainfall, sea level rise, and so on. So global mean targets in general are not very good because it also doesn't tell you what we need to do in India versus the US to keep the global mean temperature at 2 degrees. It doesn't. So 2-degree warming, as was coined first by Nordhaus in 1975 in a book on economics, cost of global warming, then the European Union picked it up, and then Stern report picked it up. It's a purely political number. Scientists in general do not like it because it is very hard to translate into any action. Okay, because the warming is not uniform, the impacts are most certainly not uniform, so global mean is not useful. I'm saying decarbonization is the best because reducing emissions as set right now are also tricky because again it comes down to what we are now calling NDCs, nationally determined contributions, where India said, let's say they will increase the carbon intensity of the GDP by 2030 with respect to 2005 by 30%. So there are a lot of caveats involved in there, baseline is involved in there, accounting becomes an issue. Whereas if you say we will just stop emitting carbon, then it's a no-brainer. Everybody has to try to reduce carbon emission and find a way to take out. So we will never go to zero carbon, but we will have what are called negative emission technologies where certain things will take out carbon. So you will emit some carbon, but you will take out more. And remember that carbon accumulates in the atmosphere because it has what is called a residence time of multiple centuries. The carbon we have been emitting since industrial revolution is accumulating in the system, in the ocean, in land, in the atmosphere. The atmospheric CO2 is increasing because it is accumulating, right? So decarbonization is a better target because that means we just don't emit carbon. Whatever we emit, we take out more than that. So temperature target is just not a useful metric, I think. And a lot of people are, yeah.
So when you say it doesn't warm uniformly, initially you said that it warms faster at the tropics, at the center where the forcing is the highest from the sun, and so this 1.5 degrees of increase essentially would be less harmful to countries on northern latitudes as opposed to those in the tropics. Is that a fair thing to say?
I want to be careful because I don't know if I have if you just Google and say global warming, your map will show up. I didn't say tropics are warming faster. I said they have already warmed more than 1.5. There are dynamic reasons why tropics tend to warm. Basically because you have a lot of humidity already and you can't get rid of more of it. But actually, higher latitudes are warming the fastest. There is something called polar amplification. If you combine your knowledge of ice albedo feedback, you should already be able to say why poles would be warming faster. Because there is ice albedo feedback there. So the polar amplification basically is making especially the northern hemisphere where the Arctic ice has been melting, is making the higher latitudes warm faster. So main thing to remember is there is a polar amplification because of ice albedo feedback, and the warming is not uniform because the heat is redistributed by the ocean, by the atmosphere, deforestation, urbanization are different, and so on. The warming is not uniform. So when you average all the warming and create 2 degrees in the global mean, it basically has no meaning. Okay.
Would you say the northern latitudes have, to a degree, a higher tolerance for the increase in temperature than those near the equator, in the sense the amount of stress that it would cause or the adaptability? In what way would the adaptability be affected with the temperature increase closer to the equator versus the northern latitude?
Well, you have to remember that, let's say, I will answer it in a slightly more philosophical way with science added later. If you think about ozone hole and the Montreal Protocol, do you think the Montreal Protocol was a success? Well, they made an agreement to remove CFCs and use HFCs, and ozone hole has generally been recovering. Okay, so it has had positive effect as intended. The problem, there's two things. One, ozone hole was going to damage all life, everybody. There was nobody safe from the ozone hole. Secondly, it was a simple silver bullet kind of solution where CFCs were to be replaced by HFCs. The problem is now HFCs are also not good at all. They are some 2,000 times worse than carbon dioxide for global warming, and they will remain in the atmosphere and ocean for 2,000 years. Okay, so I'm saying ozone hole was successfully dealt with quickly because it was dangerous to everybody. Global warming is already creating winners and losers. That is your question. Will higher latitudes be, they will be more adaptable? Imagine Siberia warms and becomes a lush agricultural land. Russia will become the biggest wheat producer in the world again. They don't care. So global warming is not bad for everybody. Global warming will and has already been creating winners and losers. Okay, there are details, of course, if contagious disease happens, which will happen more with warmer climate. Can you isolate yourself? Because of flying around, we move these pathogens very quickly everywhere. So those are other issues. Global economy makes global connections and everybody becomes vulnerable. Like 9/11, they realized that terrorism can come from anywhere. Climate conflicts are important. Already many places are having climate conflicts. For example, if sea level rises and Bangladesh becomes very vulnerable, where will they go, right? If Pakistan is already getting desiccated and losing rainfall every year, will it be a peaceful country? Are the Rohingya a climate problem? So climate change creates winners and losers. So higher latitudes obviously have an advantage. There will be many beneficiaries of climate change.
Ashfaq has a question. What solutions are proposed to the government to mitigate climate change?
Globally speaking, again, nearly all countries are involved in the negotiation, even though US, Australia, Canada, Russia, they always have back and forth, and now maybe Brazil also. 192 countries have submitted their nationally determined contributions to reducing emissions. The trickier question is, there are global governance issues. So CO2 is a very good global measure. 410 ppm is a global CO2. It translates into local effects that are very different. So solutions basically come down to what are called adaptation and mitigation. Mitigation means reducing our impact on greenhouse gases and the environment to begin with by reducing emissions, reducing energy intensity of GDP, reducing carbon intensity of energy, reducing deforestation, etc. All those are written in. Adaptation is kind of managing the unavoidable. So if India is going to have more extreme events, how do you protect your life and property at the coasts or agricultural lands, crops, etc.? So adaptation measures are involved, mitigation measures are involved, but the trickier thing is how technology will be invented and shared. For example, it's already decided that HFC has to be phased out soon. India is given up to 2035, but developing countries are given to 2025 or something. We don't know yet what will replace HFC, hydro, the coolant that is used for ACs. India as a country that's warming and getting richer will require more and more ACs, and the number is already growing exponentially. So how will we reduce our emissions while increasing ACs if we don't have the HFC replacement technology? So there are many issues involved in how technology transfer will happen, who will own the green technologies that the world will need. So it will always come down to winners and losers, haves and have-nots. Will we avoid a global tragedy of the commons? We hope so. But if anything can be learned from what is happening now under COVID, will a vaccine come along and will it be distributed to billions of people to protect everybody? We don't know yet. So these are the issues involved in solutions. There is no silver bullet, but a lot of scenarios exist on how we have to ramp up renewable energies and other things.
So I have two more questions. I will let you decide which one you want to take first. One is if you could explain microclimates and the factors that sort of create microclimates. And two is, why do you think it is so difficult to communicate really going on with climate change to people? Because a lot of people have very superficial understanding of climate change. And that is why it's very easy to manipulate them and confuse them with crosstalk. Why do you think it's so difficult to explain what is actually going on with climate change and what are all the factors that are affecting it?
Yeah, so microclimate is anything that happens kind of locally. So you can think of Amazon forest. It's big and it has so many trees, hopefully will remain so. And trees have what is called evapotranspiration. So they emit a lot of water during photosynthesis because the stomata are open and so on. So locally, it will create its own climate, which will be then on longer time scales adjusted by the global circulation. Or the Australian fire example that I mentioned, the fire became so big that it got so warm locally that it started to create its own circulation. So these kind of large scale microclimates happen, like a hurricane that is moving creates its own energy from the ocean and creates its own climate, if you want, over several days till it crashes into land. So these are all microclimates. Of course, Amazon is a longer term thing and hurricane is a very short term thing and so on. The question of why it is so difficult to communicate, the example I gave before still holds of how you yourself see risk. Can you distinguish the risk for future environment in which your kids and grandkids will grow up from saving money for them? For example, everybody thought educated women will have good job, more money, and more children. But in fact, it goes exactly the other way. Educated children and women will have fewer children. Why? Because they want to give as much resources as many resources as possible to each kid, which means ability to consume as much as possible. So, in fact, reduced population comes with increased consumption. So it is complicated when you are not able to connect future risks with your own choices. There is, of course, the simple thing that you can show where carbon dioxide is increasing, but temperature is going up and down, and you can tell people, look, there is no relation. And most people will say, yeah, I don't see a relation. That's the starting point on which you build other things saying China and India are polluting, why should we care? You can sit in the US and say, look, we have clean air and pollution is coming from there. So that is another trick you can play. Plus, in general, when you say we all have to act together, cultural differences play a big role. For example, Europe, which has seen, according to social science, which has seen resource limitations and adversity like war, has seen rationing of food, water, and energy, responds quickly with norms and punishments for shared resources like air, water, and energy, whereas US, which has not seen such limitation, immediately reacts negatively when working together with outsiders becomes part of the solution. So as soon as you say outside entities, outside regulations and rules, cultures play very differently. And nationalistic leaders can always come and say, why should we worry about pollution in China or India can say something else. So it's a very complicated shared resource management issue. It can work at any scale, even in a village, if there's a pond being shared. This is where the idea of tragedy of the commons comes from. I don't know if anybody has heard of it. Has anybody heard of tragedy of the commons? This was the idea that was introduced in the 60s by Holdren and Ehrlich, which basically used the example of a shared pasture where number of cattle grazers share it and there is no cost to sharing the pasture and everybody will get more and more cows and soon there is not enough grass for anybody. So these shared resources always tend to get abused, but Nobel laureate Elinor Ostrom showed that actually you can set up norms and punishments to manage shared resources. So global atmosphere and global ocean are shared resources. So assigning responsibility to managing them is not easy. So global warming is in general a complicated shared resource problem.
Lourdes has a question. With threat from losing large biodiversity ecosystems to development plans and government decisions, how do you see the future, for example, of India changing with regards to climate crisis?
Yeah, so India has good news in India committed strongly to Paris Climate Agreement and started an afforestation effort. The problem there has been that it was not done with community consultation, so some tribals got negatively affected, and there have been conflicts of taking over land and planting trees without worrying about native species, other details. So renewable investment has been very high in India. So there is no climate skepticism as such in India. People understand that climate is changing, and they mostly have to deal with crazy monsoon each year. So they have no problem understanding that something is changing. So one has to build on that. So quickly, the solutions have to be co-produced with people, and they have to be inclusive and equitable. Not easy, but can be done. Broader things like sea level rise and coastal erosion are not being addressed as fast or as aggressively as afforestation and renewable energy. So the silver bullet kind of solutions tends to be attractive to politicians. So that has to kind of change. And there are large scale mangrove recovery, for example, can be a blue carbon solution where you sequester carbon in coastal waters, reduce cyclone damage, reduce coastal erosion. So there is no climate science community that is very active, and government is I don't want to criticize anything, but there are lots of positives and there are lots of improvements that are possible in the way things can be done and should be done, because the impacts are getting worse by the year. Last monsoon was absolutely crazy, and if this monsoon is anything like that, 2018 and 2019 had 100-year floods in Kerala. If they get hit a couple of times more, then basically you will not recover. If you go back in the past and look at civilizations that disappeared, they didn't go extinct in one hit. They got extinct by multiple hits. So if you get hit again and again and again, you will not recover. So those kind of situations have to be kept in mind. So mixed message. There are good things happening and there are good things not happening.
But what part does biodiversity, because afforestation does not, at least to my understanding, does not aid biodiversity, because that's probably taking plants that are not indigenous or trees that are not indigenous to that area and planting them. But in terms of biodiversity and maintaining or trying to protect the natural habitats for animals and trees and plants, what impact do you think biodiversity plays on maintaining climate?
I mean, that is, biodiversity is not a very well-defined quantity. Intuitively, everybody knows what it means, but quantitative measures are not easy. Plus, biodiversity is not a fixed thing. Climates have evolved and forest compositions have evolved, but Western Ghats has a certain biodiversity which is trying to be protected, but it's a constant battle between developers and the biodiversity conservation and government regulations and government will, if you want. For example, in Kerala, rubber plantations and monocropping caused the landslides last year, not so much the rain itself. They are aware now. What will they do about it? We don't know. In the Himalayan mountains, mountain biomes have not been as well protected as they could have been or should have been. So it is a struggle of protecting what is there. And afforestation in general, it's a huge debate whether forests are really good carbon sinks at all, because as you saw in Australia or anywhere else, wildfires can cough up all that carbon in no time at all. whereas coastal carbon underwater is much more reliable and mangroves can sequester 10 times the landfalls, for example. So there are multiple choices, multiple issues, and it's a constant back and forth. So the co-benefits of biodiversity are not easily understood or explained or quantified. For example, if a tree is standing there, you know a tree is very good, beautiful, gives shade, gives this, gives fruits, whatever. But what is its value? We don't know. But if you cut it and make furniture, you can immediately say what its value is. So putting value on biodiversity is not easy. There are concepts of ecosystem services which count forests as worth $1 trillion, but a developer will tell you he can build something for double that value. So it's a human mind is not able to put value on some things, and biodiversity is one of those things. It's a very complicated issue.
I think maybe reframe the question in terms of like what part does, for instance, a wolf play in maintaining a forest or maintaining the biodiversity within an area, because that forest, say it were functioning well and it were sequestering carbon, how do all the parts, because biodiversity means all the different parts that work in that ecosystem that work together, at least to me. So why is it that each player or each animal or each tree is important within that system?
Yeah, you can build networks and show that the ecosystems that are heavily networked, interdependent, are more stable. So you can define a health of a ecosystem in terms of its complexity, how many species there are, in terms of resilience, so how quickly it will recover from a perturbation, and its productivity, total amount of output it can give. But when you say wolf, for example, they reintroduced wolf in Yellowstone, and there is some data saying yes, they play an important role. But mammoths disappeared 5,000 years ago. What happened? Right? Everywhere humans went, for example, they went to Australia and nearly killed all the megafauna. So it's hard. It's a time varying thing. Sometimes natural extinctions happen, and sometimes humans have driven things to extinction. But the rule is nature makes the rules and biology finds the loopholes. So biology manages to survive when there is a perturbation, whether it comes from humans or not. So to think that we can save everything may be wrong, but to think that we can destroy whatever we want is also wrong. So there is a balance that has to be found, that has to be based on some kind of a value system rather than trying to assign a role. There are experiments done. Is there any species we can get rid of without any damage to the ecosystem? Turns out that even mosquitoes are useful. Maybe we are not useful. If we kill us, what will happen? Probably nothing, right? So these kind of exercises are mentally useful, but then you have to go all the way to the philosophical question of why have we evolved this way? If you think that universe is dissipating energy and life is dissipating energy, then we are really good at dissipating energy. Maybe that's what we evolved to be, just to dissipate energy as fast as possible. So we have to find our own limits to say, are we really in charge, or are we really able to save something from ourselves, or are we just out of control? We don't know. So for me, it's a very deep question that cannot be answered by thinking of wolves and so on. But to say, for example, in Columbia, Maryland, they tried to bring trees close to neighborhoods they were building. Then parents started complaining that trees are building deers and deer are bringing ticks and Lyme disease is coming. What do you do? So system is complicated and we are going everywhere. And we try to change the system to fit our needs, and we don't necessarily fit ourselves to the system that exists. But are we supposed to do that because of our evolution? I don't know. So for me, biodiversity is important. It has a role to play, but it's not clear what our role is in maintaining or destroying biodiversity, or if we are just going to find out when it's too late.
Okay, we've crossed our time limit, but Vignesh has one question, so I'll ask the last question and then I think we can conclude for today. His question is, what is a good ppm for our planet in terms of, I'm assuming, carbon parts per million for our planet? A healthy
Yeah, so that goes back to the question I asked before. For example, it was 1,000 ppm or higher when the dinosaurs were around. So you are basically asking what is safe for humans. So it depends on various factors. First of all, technology. For example, we are already at 400. We started at 290 before Industrial Revolution, and we are living at 400. And it's a question of what will happen if we go to 600 or 700. How will sea level change? How will temperatures change? How will humidity change? How will wet bulb temperature change? How will extreme events change? But if technology will allow us to protect ourselves against all those things, then what? So it cannot be answered in isolation. It has to be answered in the context of biodiversity. For example, what other species will go extinct if we go to 700? Do we need those species? Can we really protect ourselves? So philosophically speaking, Jim Hansen from NASA already said we have to go back to 350. It's hard for me to imagine right now how we'll go back to 350, but with technology, it may be possible. So I would say just don't try to go, right now we're at 415. You can kind of calculate how much more carbon you will be putting on the current emission rate and where it will take us by 2030 or 2050, and what energy systems will replace that will try to bring us back. So at some point, it will be a question of how much carbon we can take out versus how much we'll put in. So I think I would say 500 seems like already a very high number, but technology make it possible for us to live in higher ppm.
But none of that technology exists now. As it stands, none of that technology is scalable.
It depends on how rich you are, right? If you are living in Delhi with AC and filter in the car, and US consulate makes all its staff buy air filters for home and cars, and they are living there. So depends on who will be able to live and who won't be able to live.
So it is an inequality game at the end.
It always comes down to that, unless population drops to a level where, for example, if Norway has an unemployment rate of 1%, 1.5%, they have to play a janitor as much as a doctor to get anybody to do the cleaning of toilets. So if population is low enough, then maybe everybody will be given the facilities to live well.
Do we have any more questions? Because we have crossed our time. Okay, I think we conclude today. Thank you so much.
All right.
Doctor, I'll get in touch with you to schedule our next session so we can continue where we left off. Thank you all so much for joining, and feel free to send us any additional questions you have so that we can I can bring them up for our next session. If there's anything at all anyone would like to contribute or add, please email us at climateschool@gmail.com. All right, thank you.
All right, bye-bye.